This is the EdExcel AS Level Maths Paper 2, covering the Mechanics module, and this is from the 2022 series. Question number 1. The point A is 1.8 meters vertically above horizontal ground. At time t equals 0, a small stone is projected vertically upwards with speed u meters per second from point A. At time t equals t seconds, the stone hits the ground. The speed of the stone as it hits the ground is 10 meters per second. In an initial model of the motion of the stone as it moves from A to where it hits the ground, the stone is modelled as a particle moving freely under gravity. The acceleration due to gravity is modelled as having magnitude 10 meters per second squared. Using the model for part A, we have defined the value of u. Well, for part A, here is a diagram representing the situation. We've got horizontal ground. We've got the point A, which is 1.8 meters above the horizontal ground. The stone is projected from A with speed u meters per second upwards, and then as the stone moves, it hits the ground with speed 10 meters per second. The acceleration due to gravity is 10 meters per second squared. And what we want to do is find out the value of u. To do this, we can use v squared equals u squared plus 2as. So, using v squared equals u squared plus 2as, if we take upwards as positive, then we have minus 10 squared equals u squared plus 2 multiplied by a. Now a will equal negative 10 because we are treating upwards as positive, multiplied by s, and s will be negative 1.8 because the displacement will be negative if we take the A level as the 0 level. So we have 100 equals u squared plus 36, and from this we can conclude u equals the square root of 64, which is 8. So u equals 8. Then for part B, we have to find the value of t. We can find t using s equals ut plus a half at squared. And so, for part B of the question, using s equals ut plus 1/2 at squared, we have s, which is negative 1.8, and that's equal to u, which is 8 multiplied by t plus 1/2 multiplied by a, which is -10, multiplied by t squared. We need to find what t is. So if we rearrange, we have minus 5t squared plus 8t plus 1.8 equals 0. So we can solve this quadratic to find the values of t. We have minus 5t squared plus 8t plus 1.8. It turns out t equals 1.8 and t equals minus 0.2. And so therefore, the value of t, that's 1.8 only. Now for part C, we have to suggest one refinement apart from including air resistance that would make the model more realistic. For part C, we could use a more accurate value of g. And then for part D, in reality the stone will not move freely under gravity and will be subject to air resistance. We have to explain how this would affect the answer to part A. Well, for part D, the initial velocity will be greater than the value calculated in part A, and that's because air resistance will have slowed it down. And so, to have the same final velocity, u would be greater. Question number 2. A train travels along a straight horizontal track from station P to station Q. In a model of the motion of the train at time t equals 0, the train starts from rest at P and moves with constant acceleration until it reaches its maximum speed of 25 meters per second. The train then travels at this constant speed of 25 meters per second before finally moving with constant deceleration until it comes to rest at Q. The time spent decelerating is 4 times the time spent accelerating. The journey from P to Q takes 700 seconds. Using the model, for part A, we have to sketch a speed time graph for the motion of the train between the two stations, P and Q. So for part A, for the first part of the journey, we know that it starts from rest and it moves with constant acceleration until it reaches a maximum speed of 25 meters per second. And so, here we have the first part of the journey, and this takes us to 25 meters per second. After that, it travels with constant speed, so for the next part of the journey, it travels with constant speed, and then it has constant deceleration until it comes to rest at the point Q. So, here, for this third part of the journey, it comes to rest. And what we also know is the journey from P to Q takes 700 seconds. And so here we have 700 seconds. Now, what we need to do is, now that we've sketched the speed time graph for part B, we are given that the distance between the two stations is 15 kilometers, and using the model, we have to show that the time spent accelerating by the train is 40 seconds. If we let the time accelerating be t, that means if we take a look at the different sections of the graph, this time from here to here will be t, the time from here to here, well, what we know is the time spent decelerating is 4 times the time spent accelerating, which means this time will be 4t. And if the total time is 700, that means that this time here will be 700 subtract 40 subtract another t, so that's 700 subtract 5t. And we know that the total distance is 15 kilometers, and what we can do is find out the area of this trapezium and equate that to 15,000. So we have 1/2 multiplied by, well, to work out the area of a trapezium, we've got 1/2 times the sum of the two parallel sides. So we have the 700 subtract 5t plus 700 multiplied by the height, which is 25, and that's equal to 15,000. So now let's try to simplify this. 15,000 divided by 25, that's 600, and if I multiply this by 2, we get 1,200, and that will equal 1,400 subtract 5t. And so we have 5t equaling 200, which means t is equal to 40. So we have t equals 40. And if we go back to the question, that's exactly what we wanted to show, that the time spent accelerating by the train, which we said is t, that's 40 seconds. Then for part C, we have to find the acceleration in meters per second squared of the train. So for part C of the question, for the acceleration, that will equal the gradient of this line. So we have 25 over t for the acceleration. but we know what t is, that's 40. So the acceleration is 25 over 40, and it turns out the acceleration then is 0.625 meters per second squared. Then, for part D, we have to find the speed of the train 572 seconds after leaving P. Well, for part D, if we know that t is 40, that means here we have 40, and then here we have 700 take away 5 times 40, which is 500, and 4 times 40, that will be 160. Now, in this question, we want to find the speed of the train 572 seconds after leaving P. So where is 572? Well, 40 plus 500, that's 540. 572 will be somewhere over here then. So here we have 572, and here we have the 160. And what we need to do in this question, we need to find the corresponding v value. So to do this, we can use similar triangles. First of all, from 572 to 700, that's 128. So we've got two similar triangles. Here we've got 160, and the height will be 25. Here we've got 128, and we are finding this height. We'll call it h for now. And so we have 25 over h equals 160 over 128. So we have 160 divided by 128, which is 5 over 4. So h then will equal 25 divided by 5 over 4, which is 20. So h is equal to 20. And then for part E, we have to state one limitation of the model which could affect your answers to part B and C. So the train is not likely to actually have constant acceleration because it may experience air resistance, which will increase as the speed increases. Question number 3. A fixed point O lies on a straight line. A particle moves along the straight line at time t seconds, where t is greater or equal to 0. The distance, s meters, of P from O is given by s equals 1/3 t cubed minus 5 over 2 t squared plus 6t. And for part A, we have to find the acceleration of P at each of the times when P is at instantaneous rest. Well, if we know what S is, we can find out what V is and what A is. So, for part A, S is equal to one-third t cubed subtract 5/2 t squared plus 6t. And so V is equal to ds over dt. So if I differentiate with respect to time s, we end up with t squared minus 5t plus 6. A is equal to dv over dt, so that's 2t minus 5. Now, because we are concerned with instantaneous rest, well, it's resting when it doesn't move, which means that when v equals 0, t squared minus 5t plus 6 equals 0. So I've got t minus 2 multiplied by t minus 3 equals 0. In other words, it's instantaneously at rest at time t equals 2 seconds and 3 seconds. And what we are required to do in this question is to find the acceleration of p at these times. So, when t is equal to 2, a is equal to 2 multiplied by 2 minus 5, which is minus 1 meters per second squared. And when t equals 3, the acceleration, we've got 2 multiplied by 3 minus 5, which is equal to 1 meters per second squared. And now we have to find the total distance travelled by p in the interval 0 to 4. Now, the best way to think about this problem is to actually sketch a curve. So if I quickly sketch a curve, I know that it starts at the origin, and I'm considering what happens up to 4. Now, let's plot the displacement s against time. Now, I know that when t equals 2, I've got a stationary point. And I know when t equals 3, I have another stationary point. Now, when t equals 2 to t equals 3, I know that I'm decelerating. And I know when t equals 3, that's when I start to accelerate. So I'm expecting my curve to look something like this. And what I can do is find out the displacements at t equals 2, t equals 3, and t equals 4. So, for part B of the question, let's see what happens when t equals 2. When t equals 2, s is equal to 1/3 multiplied by 2 cubed minus 5/2 multiplied by 2 squared plus 6 multiplied by 2. And if I work out what this is, it turns out I get 14 over 3. And when t equals 3, s is equal to 1/3 multiplied by 3 cubed minus 5 over 2 times 3 squared plus 6 multiplied by 3. And it turns out I get 9 over 2. Now let's see what happens when t equals 4. When t equals 4, s equals 1/3 times by 4 cubed, subtract 5 over 2 times by 4 squared plus 6 multiplied by 4, and it turns out we get 16 over 3. So now let's sketch s against t between 0 and 4. So here we've got the graph of s of t. Now I know that when t equals 2, I have 14 over 3. So at this point, I have 2 and 14 over 3. I know when t equals 3, I've got 9 over 2. So here I've got 3, 9 over 2. And I know that when t equals 4, I have 16 over 3. So when t equals 4, s is equal to 16 over 3. Now I need to find the total distance. So for the total distance, well, I have 14 over 3, which takes me to this point here. And then I will add on to this the distance from here to here. Now that distance is the difference between 14 over 3 and 9 over 2. And then I've got the distance from here to here, which is the difference between 16 over 3 and 9 over 2. So what I need to do now is work out what this is, and it turns out we end up with 17 over 3. And if I work out what 17 over 3 is as a decimal, we get 5.67. So we have 5.67 meters given to 3 significant figures. Question number 4. A vertical rope PQ has its end Q attached to the top of a small lift cage. The lift cage has a mass of 40 kilograms and carries a block of mass 10 kilograms as we see in figure 1. The lift cage is raised vertically by moving the end of P of the rope vertically upwards with constant acceleration 0.2 meters per second squared. The rope is modelled as being light and inextensible, and air resistance is ignored. Using the model, we have to find the tension in the rope PQ. So for part A, if I draw a diagram for the entire cage and the block, I've got the weight of the entire thing, 50 g, that's by adding 40 kg to the 10 kg, and I've also got the tension in the rope. and that's what I need to find, the tension. So, to find out the tension, we can use the sum of the forces is equal to the mass times the acceleration. So, we've got T minus 50 G, and that's equal to 50 multiplied by A. I know what A is, that's 0.2. So I've got T minus 50 G equals 50 multiplied by 0.2. And therefore, if I find out what T is, 50 times 0.2 plus 50 times 9.8, that's 500. So we have 500 newtons. Then for part B, we have to find the magnitude of the force exerted on the block by the lift gauge. So here is a diagram for part B. We've got the block, it's got a weight of 10 kilograms, so the force here is 10 G. We've got the reaction force R, which is what we need to find. So, again, using the sum of the forces is equal to the mass times acceleration, we've got R subtract 10G equals 10A, and knowing that A is equal to 0.2, we have R minus 10G equals 10 multiplied by 0.2, which means R is equal to 100 newtons.